So, continuing discussing about solids, there is a concept which is nets of solids. So, a net of a solid shape is basically a 2D representation of a 3D solid. So, if all done like dices in the past when you were in primary, right? So, if you take a sheet of paper, right, and then you can make a drawing, right, with some squares, and then you can put some squares here on the side, and then if you cut this shape and you fold it properly, you could actually get a cube, right? If you fold it like this part here, those two borders up, this up, this up, and this closes the top, you'd get a cube. So this is a net of a solid. Which one? A cube. Right, so here we have a few possible nets, and here we have some solids. So I would like you to pause the video now and try to check which of those are actual nets, if there's any which is not a net, and if there is any connection between those nets and those solids. Okay, so let's analyze. Well, this first one is a cone. Well, we have a cone here. If we fold this, we can get back to this solid. And this is the cylinder, right? So this is done. This A would be 6, I would be 3. What about this shape? Right, so that's a prism, a triangular prism. So if we try and look for triangular prisms, this is a triangular prism, right? So if we fold it, we could get back to this shape. So this could be number 5. What about this? That's a pyramid, a triangular pyramid. If all those triangles are equilateral triangles, then we have a special name, which is the tetrahedron. So this could be a tetrahedron, right, if all triangles are equilateral. So let's check if we have anything that is similar to that shape here. Well, this one, right, if we fold it, it's a bit different than the other ones that we've seen, but it still works, right? If you fold it, you would be able to get back to this shape. So C1, our tetrahedron, right, or triangular pyramid. It's a regular triangle pyramid. What about this one? That's a pentagon, right? So the base is a pentagon, and this kind of shape is a prism. So a pentagon based prism. So let's look for it. Well, here it is, right? So D8. Now this is a pyramid. So we've got 5 sides, so it's also a pentagon. So we have to look for a pentagon and 5 sides. So here we are, right? In the pyramid. So we've got triangles, which are those sides, and we've got this pentagon, which is the base. So E2, and now the other ones are quite easy, right? So this is roughly a cube, so that would be 7, which is almost the example that I've shown you, but it's a different way to fold, to have a net. There are many possibilities, right? There's not only one solution. Now for letter G, it would probably be 9, right? That's a prism, it's a square base, and H is a square-based pyramid, so that's 4. So the actual last content of this chapter is volumes. So we'll investigate volumes for several different shapes, and basically each one of the solids that we have covered before. So the simplest one is a prism. So well, let's say that I have a square, right? A square-based pyramid. Prism. So this is a prism, right? Could be a cube. I'm not telling you if the lengths are the same. So let's say if this is length A, this is length B, and this is H, height H. So it's actually fairly simple. You would just multiply all those three values, which would mean the same thing as, for example, when you multiply A and B, that's the same thing as getting the area of this shape that you're using to make your prism. So it's the base of the area times the height. So base of the area times the height. Why use base of the area and not multiply those numbers? Well, because you might have a shape with a different area that wouldn't be the area of a square or a rectangle. For example, here I've got a pentagon, so you would have some lines here which would be dashed, right, which are behind. So it's a pentagon. So in this case we would need, so in this case we would need first to find what is the area of the base or the top, doesn't matter, it's the same thing, right? So here, this area, and then we multiply by this height. So it's fairly simple. It gets more complicated when you're talking about other shapes like cone, cylinder. Now the cylinder is actually still the same equation, because when we have pi r squared times h, pi r squared is the area of a circle. So what you're doing here, it's the same thing. This is the area, which particularly in this case would be pi r squared, and this is your height. So for you to calculate the volume, you would just multiply pi r squared, which is your area, by the height. So pi r squared h. Alright. Now other shapes, they're more complicated. For example, the volume of a sphere, we would need calculus for this one. The cone, it's also not very simple, but there are some comparisons that we can make. For example, if you compare the volume of a cone and the volume of a cylinder, so if I have, let's say, a cone, right, and a cylinder, and let's say that they have the same radius here, radius r. So the base here is basically the same. Comparing those two, we can clearly see that, let me see if I'm going to, oh, not going to work. So we can clearly see pi r squared h, pi r squared h. So if they are, so if you have a cone and a cylinder of the same height and same base area, the volume of this cone would be 1/3 of the volume of this cylinder. So if this cylinder has volume V, the volume of this one would be V over 3. And you can see that just by comparing the formulas, right? Now the pyramid, you can see that it's a very similar situation to comparing cones and cylinders. So if you have, it doesn't matter here which base, so let's take a square base, okay? So let's say that I have this pyramid, and I have a prism which is the same height, so it's of the same height, and the base is the same, okay? So this area and this area, they are the same, A and A. So this is height h, which is the same for this. If we compare the volumes, it's also a factor of 1/3. So you can see it's the same thing, base area times height, with a factor of 1/3. So if this volume was V, this would be V over 3 as well. So we've got an example here. Take your time to read the question, right? So we have a river, or sorry, a lake, and we're given the area of this river and the average depth. So we can assume that it's just like a prism with a rectangular base, right? So if we're calculating the volume of this prism, it would simply be area of the base times height. So in this case, it's 85,000 square meters times the height, which is 28 meters. So if you crunch the numbers down, you should get to a value of 2,380,000 squared meters. And then it's the kind of number that eventually in the future you might think of changing units. For example, here squared meters might not be the best choice. So if we wanted to change this to squared kilometers, we could, and this would be 2.38 squared kilometers, which makes more sense. So what about this case now? We have a cylinder, right, and we're given the radius, which is 2, and the height, which is 7.5. This is just the application of the formula. So volume is area of the base times height. So pi r squared h, right? So pi r squared, so r is 2, so that's 2 squared. Our result will be in centimeters cubed times 7.5. I think I just realized that there was a mistake in the previous question, because it should be cubic millimeters, so those results were not accurate. I will redo it in a minute. So 2 squared times 7.5 centimeters. That would be what? Take those numbers, put in the calculator, should be 94.2. Cubic centimeters, right? Fairly simple. Now the problem, the previous question was just the unit. I wrote down the unit as meters squared, but it should be meters cubed because it's the volume. It doesn't make any sense to have squared. So that result in squared kilometers is also wrong, because it should be cubic kilometers cubed, and the number would be different. You would have an extra 1,000. So please do not take into consideration the previous result in kilometers. Okay, so another example now. So find the volume of this triangular prism whose base is an isosceles triangle where the equal sides are 12 centimeters and the angle between them is 130. The height of the prism is 15 centimeters. So we have to find the area of the space first. So you should remember, we have a triangle which is it's not a right angled triangle. So we'll have to adjust this. It's going to be half. We're going to multiply the two sides, which in this case they are the same, so squared, times the sine of the angle between them. Usually if this is a right triangle, the sine will be sine of 90, so that would be 1. So we get back to the equation that you've learned on your class 5, class 7, okay? So 12 squared is 144 over 2 sine of 130, right? So yeah, let's leave it like that, because we want to find the volume. So let's try not to get any approximation errors, because if we multiply those, we're going to get sine, and that might be a broken number. So let's just do the volume. It's area times height, area of the base times height. So that's this times the 15 centimeters, which is the height. So it's basically 15 times 144 divided by 2 times sine of 130. And that would be 827 cubic centimeters. Okay, remember that this is always to the power 3 because we're calculating volumes. All right, and that's it. Now a couple more examples, and those are actually fairly simple. It's just application of formulas, right? So calculate the volume of each solid. So for the first one, volume, this is a triangular prism, so it's a third, right? And the same thing if it was a triangular pyramid, square based pyramid. So it's 1/3 of the area of its analog as a prism. So what would be the volume of a prism with those characteristics? We just multiply all of those. So it would be 4 times, so this times 4 times 7.4 times 3.5. I'm just multiplying here all the lengths, and then in this case the result would be 34.5 cubic centimeters. For letter B, it's again a third, and it's analog as a cylinder. So if we had a cylinder with those characteristics, pi r squared, so pi r is 3.2 squared times the height, 11.5, right? So the value would be 11.5 is actually this side. It's not what we need. So we need to find the height first. So to find the height, let's make a triangle. This is going to be a right triangle. This is our height h. This is 11.5 and this is 3.2. So using our trigonometry, we can find the height, just use Pythagoras. We can find the height to be approximately 11. Okay, so this will be 11.0 something, 04, so it's approximately 11. Okay, up to 3 significant figures, 11.0. So if we multiply those numbers here, we'll find 118 cubic centimeters. There you go. So our last example, we have a canister, some kind of container with tennis balls, and we want to find the volume which is occupied by air. We don't want the volume occupied by the balls. So we're given the diameter of each of those balls, and it's the same diameter as the cylinder. So what would be the volume of each of those balls? So we have to look for the volume of a sphere. So the volume of a sphere is 4/3 pi r to the power 3, right? So using this relation, we know the diameter, which is 6, so our radius is 3. So the volume of one of those balls would be 4/3 pi 3 to the power 3, and I'll leave it like that for now. We know that there are 3 balls, so the volume of all those 3 balls will be 3 times 4/3 pi 3 to the power 3. So we can actually cross out some of those 3's. That would be 12 pi. That's the volume, 12 pi cubic centimeters, right? That's the volume occupied by the spheres. Now what about the cylinder? So the cylinder, it's, well, pi r squared, which is the base, times the height. Now if the diameter of those balls is 6, the height will be 18. So this volume would be pi, the radius is the same, so that's 3 squared, and the height is 3 times 6, right? So 18. So if we work out those numbers, that's 3 squared, which is 9. So 9 times 18. So 162 pi. Okay, if I'm not mistaken, I think that's the value. So we just subtract those two. The empty space would be 162 pi, right? The empty volume, 162 pi minus 12 pi, which would be 160 pi cubic centimeters. Uh-oh, there's something odd here. I've crossed, something's wrong here. This should be multiplying. This is not 12. Okay, so here I could not cross those. They're multiplying each other. So I could cross one of those out, but I will still have 3 to the power 3 on top. So 3 to the power 3, that's 27, right? So it's 108 pi. Now it's more reasonable. So this is minus 108 pi, and then 168 minus 108, that's gonna be 50. Is everything right? Yeah, that's it. So that's 54 pi. And this time, yeah, makes sense.